Hey everybody, this is Larry. This is week 3 of the weekly premium Leetcode challenge. I don't know how I say it. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you get about let me know what you think about this one. Have I solved it yet? No. Yes, new problem, exciting. Map 3189, minimum moves to get a peaceful board. Given a 2D array rooks of length n, where rooks of I is someplace. On an n-by-n chessboard, your task is to move the rook one at a time such that the board becomes peaceful. The board is peaceful if there is exactly one rook in each row and column. Return the minimum number of moves required to get a peaceful board. Note that there are no point at no point can there be two rooks in the same cell. Okay, I mean that makes sense. Do we have exactly n rooks? We have n rooks and n chessboard. Okay, and n is 500. So okay, so I mean, I think honestly the first idea that I had was I think my first idea is greedy, some sort of greedy, right? But yeah, but I think maybe it's still some sort of greedy. But my second idea is actually max flow, which I'm not going to go over. But you can think about this as you can think of this as a max flow problem. That's all I'm going to go with that one. I mean, I don't think it's fast enough for this problem, so it has to be better than that. But you can also think about this as just like a maximum bipartite matching type thing, right? So there's definitely some solutions there along the way for that, right? Oh, it's n, I guess. Yeah, whatever. Yeah. So. Did I misunderstood this one? Oh. Oh, actually, maybe I misread this one. I was like, because my greedy solution, honestly, was thinking about, my greedy solution was just about, I misread this one a little bit. I mean, I think what I said about max flow and stuff still works. That part actually is pretty okay, but I misread this one. Because I didn't know that why would, because it's a rook. I get that it can attack. Well, actually, they don't even explain what a rook is, so that's actually a little bit weird, honestly. But like they should, because you can't assume people know what a rook is. Because if you assume people know what a rook is, and then you just say that you can only move them one cell at a time, which is also not a rook, then, right? It's very weird, this one. It's just not a rook. They could call it, they should just name it something else and then just redefine it like what you want it to do. Anyway, ranting aside, one cell at a time. Okay, so I was like, how do you get 6 here? Because my first initial greedy solution is just that, okay, well, if it overlaps, then you can always move to one place where, like, if you have two rooks in the same vertical, you can always make one move to go to a place where it doesn't overlap in the vertical, and it always takes one move. So you can kind of do that for each. I think you could even do it for rows and columns independently, and that'll be fine because if you're on this, because it takes one move, and then if you're at that column, even if you're on the same row with someone else, you just take one more move to do it, and and that's fine because yeah, and you could because there's n rooks in n by n board, so a lot of pigeonhole principles, or you can kind of prove that it just everything kind of fits in that way. That said, that's not the problem that we're given today, right? The problem is that yeah, the problem is that you can only move one cell at a time, which makes it a little bit more interesting for sure. Okay. I think one thing to note is that I always say this, but sometimes it's worth bringing it up again, is that examples always sometimes try to trick you. For example, here, even though they tell you that no point can there be two work in the same cell, actually it doesn't matter. What I mean by that is that for this example one, there is this idea that well, two things, right? One is that, okay, let me draw it out so that's a little bit more obvious. And let me actually use the actual drawing board. Hang on. Where's my pen? Okay. Yeah, so basically you have something like this, and I'm just going to draw it very terribly. So you have do, right? But the thing is that, well, there are two things. One is that the moves is 3, so you can actually, the examples kind of fool you a little bit, but you can actually go, say, 1, 2, 3, and it's the same 3 moves. And in fact, you can also go 1, 2, 3, the same moves, right? So that's a key observation. I mean, you could say that you're not supposed to share the same space, and I don't think there's an edge case that could make it make that true, because the end state is all that matters, right? So that, and you cannot have two rooks in the same place in the end state. So the transition states don't really matter, is what I mean, right? Because you're always going to keep moving. So that another way, and that makes sense, I hope. But if you really want to prove, then it's just finding the proof that if this cell goes to here and here goes to here, then you can always do the moves in the opposite order, which is what they do, right? Which is that you go here first, and then this one goes here, and then you have the same state as just going here, in 2 moves. So that's basically the principle that I would try to think first, right? So that you can ignore this part. Okay, right? Whew. So then how would we want to do it? Well, honestly, I think it is still the same thing that I said. It's just that the moves are calculated differently. And what I mean by that is a greedy way. Yeah. Right? Basically, and I think one thing that you can actually do in this one that I kind of alluded to already is that you can actually, and it may be surprising, but for this particular problem, you can actually separate the dimensions. So you don't really need a square board. You just need to do 2 things, or run it twice. One for where the on which row they are, and then one for in which column they are, right? Because, yeah, the reason is because you have to move them out of the way anyway. So here, maybe one way that you can think about it is that rows is equal to 0 times n, right? And then I think there's a smarter way to do it. Well, 500 squares is fast enough. So actually, yeah, you can actually do this in this is such a cool problem, actually, because there's so many optimizations that I'm thinking of right now, honestly. But for example, you can do something like well, that's just right, x in range of n for y in range of n, and then you could say if work sub xy is I didn't know that we're not getting a grid. I mean, I should have known, but But yeah, so actually this is even easier, right? Which is that for xy in works, you have, is this zero base index, x, right? And then the idea here is then, and you do it separately anyway, is that you can do something like for x in rows, or for, yeah, x in rows is fine, right? So then maybe you have current is equal to 0, right? So then if x plus current, and maybe just like moves, right? Moves is equal to 0. If x plus current is greater than 1, then current is equal to the idea is that if you have more than one, they all have to move together. So you can kind of do it all together. Well, one current is equal to x plus current minus 1. Yeah. But then the moves, so moves you add current, because that means that the current is I know that's a bad name. So current is the number of pieces to the left that you're moving, right? So okay, so that's basically the idea for moving to from left to right. But then the problem is that if x is 0, what happens? So this is good, and then you continue, I suppose. Well, this is, yeah, this is greater than 1, or greater than or equal to 1. Yeah, that's fine. And then else we need to carry from forward. So this is the hard part that I'm trying to think. If I can do some like negative math. And I think we can. Right? Because you could do it in a reverse deficit kind of way. I'm trying to convince myself a little bit. So, I mean, given that n is 500, what you can do is also do a second for loop to get the next one, and then just move it manually and calculate it, right? So we can do it that way for sure. But I think you can actually carry the negative in a way, because that means that, so this is 0. So x plus current is equal to 0 or less than 0. So then now, right, or less than or equal to 0. So that means that we need to steal from the future, right? And this assumes that current is greater than 0. But okay, so if it's 0, then what happens? Or if x plus current is equal to 0, what happens? Well, you need to carry one from the future anyway. So that means that there is a 1 yeah, maybe I would write this actually as current we added x. So then now we can just write this, and then now this we subtract from 1. Oops. Right? Else I think the order is also a little bit tricky. So we need to steal from the future. So I'm just going through the cases in my head, right? So, okay. So then now we add it to the thing, right? So let's say if current is equal to 0, then here, right? We still want to subtract from 1. So we borrow it from the future. So maybe I think this works. But I don't know, to be honest. And then yeah, because that is the debt. And then it just summed over time. I think maybe that works. Oops. Moves plus absolute current at the very end. So that's basically the idea, right? I'm going to run it real quick. I know that this doesn't work because this is just on rows and columns. or rows. So this 6 is kind of concerning, but it's I forget that x can be up to 4. Well, it could be a lot in general. So okay, so then you have 4 here, 0, 4, 3. So 3, 2, 1. Oh, actually, this is right. No, this is right because we only care about rows. So, okay. I mean, I just want to write something like calc because we're just going to... Sorry that I'm not that explaining it because I think I'm not convinced on this one 100%. But, and I know that these overlap, but I just want to kind of run it real quick. And then maybe just submit it real quick and maybe we'll get wrong answer, but that's fine. But okay, cool. Yeah, I mean, that's what I thought about the dead thing, right? We steal from the future. So, I mean, I know that this is actually kind of like crazy looking though, right? Like that's the thing is that I wrote it this way and you watch me write it this way because I'm thinking through all the cases. And the idea here with the negative is that when you have negative moves, you assume that you already basically what I call the dead is that you know that if at a current cell you have a -2, that means that 3 of them will come from the future, right? Or you make 2 moves in the future to get here. So that's basically the idea. And of course, I know that this overlaps, right? So then if you write something crazy like this, or maybe, you know, yeah, if you write something crazy like this, it's not understandable. Or like, you know, I mean, I don't know if it's not understandable, but it's just way harder to understand, right? So definitely, yeah. But yeah, that's all I have for this one. This is actually, well, yeah, this is going to be linear time, linear space, because this is linear and this is linear. Keeping in mind that the input size is what the linear depends on, right? And the input size is actually just n things, not n by n board. So therefore, it is linear in the size of the input and in time and space, right? Because this is a linear for loop, and we do it twice, and that's it. 2 times linear, if you will. Yeah, that's all I have for this one. This is an interesting one, and I don't know why. I took a long time on this one because I'm trying to think of all the proofs in my head, but also honestly, I just misread it a little bit in the beginning. But yeah, but I would also say that given the n is equal to 500, you can obviously also do this in n square, and it'll probably be fine. I don't know how to do it in n square actually, but I mean, I guess we did it with n square because the idea here, if you don't do the thing about the dead that I talked about, right? In theory, you could just get the next item that is non-zero and then just move it manually and stuff like this, right? So that's not that bad. You could do that in n square, and probably you could sort. I mean, I guess I don't know. I mean, yeah, you could sort it. I guess counting sort is what I'm doing. Counting sort, I guess so. I guess this is basically what I'm doing. So, okay. But I don't know if I would, you know. I don't know. Yeah, I don't know. I don't know about what they say, but yeah. Hope this was good. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.